All right, so sorry we hit that 15-minute mark at a tough time. All we had left was the answer. It's good to, I went ahead and finished it off. It's good to check the numerator to see if it factors. So what we want to think about is our master product, 4 times -6. Are there factors of -24 that add or subtract to be 3? And I don't believe there are. We have 2 and 12, 3 and 8, 4 and 6, so we can't get that. It doesn't factor. So there's our final answer, and we can just leave it like that. I would hope you don't need to pause, since you would have had time to finish that off between videos. So I'm going to move on. Looking at example 5. I like to list my LCD. So my LCD is the unique factors of the denominator. The first denominator has a factor of x. The second one has a factor of 3 and y. They're all unique. They all are to the power of 1. So my LCD then is going to be 3xy. The first term is missing the 3 and the y, so I'm going to multiply top and bottom by 3y over 3y. Top and bottom by 3y. So we get 2y, where 3y over 3y times 2y over x minus 4x over 3y, and this denominator is missing the x from the LCD, so we're going to multiply top and bottom by x, and then we're going to simplify. 3y times 2y is 6y squared minus 4x times x is 4x squared. And if you want to write them over different denominators at first, that's fine. You'll eventually write it over one denominator. 6y squared minus 4x squared all over 3xy. So while the top does factor, you can factor out a 2. Factoring out the 2 does not help us. The 2 will not reduce. So I tend to just leave it like this. So factor if it helps, don't factor if it doesn't help. And you can go ahead and pause if you want. I'm going to move on to the next example. Alright, this example has kind of a unique issue in it we hadn't brought up in our earlier list of things to do. So we know we're going to need an LCD. So when we find the LCD, we want to factor the numerator and factor the denominators. So the first denominator does not factor. The second one will factor to x minus 5 times x plus 1. And if we look at the numerator, we notice it does factor. It factors to 2 times x plus 1. And here's where reducing is very, very helpful. If we don't reduce these out, we're going to we could easily run into a very difficult factoring problem later. So we're going to go ahead and cancel these x plus 1's out. And what that does is it reduces our LCD by a factor, which is exceedingly helpful. So while these two denominators look similar, in terms of least common denominator, they're quite different. Our LCD is now going to be the 3x minus 5 and the x minus 5. So our goal is to get a common denominator. The first term doesn't have the x minus 5 in the denominator, so we're going to multiply top and bottom by x minus 5. Remember the value of this thing in blue, the value of this is 1, so I'm just multiplying the first term by 1. And I'm going to multiply the second term. It's missing the 3x minus 5 in its denominator. So top and bottom by 3x minus 5. And the value of This thing here in green is 1, so I'm multiplying that second term by 1 also. When I distribute, I get x squared minus 5x all over x minus 5 times 3x minus 5, minus, distributing that 2 gives me 6x minus 10 all over x minus 5 times 3x minus 5. I think I'm going to run out of room. Now, instead of subtracting, I would rather add the opposite, so I'm going to change that to addition and change these signs. And then I'm going to combine my like terms. So x squared has no like terms. Negative 5x, negative 6x is going to be minus 11x plus 10. I do not distribute the denominator. Leave it in factored form. Are there factors of 10 that add to be negative 11? Well, I think there are. Negative 10 times negative 1 would be positive 10. And negative 10 minus 1 would be 11. But what we notice is that this doesn't help us. We don't have an x minus 10 in the bottom. We don't have an x minus 1 in the bottom. So while it factors, factoring is not useful to us. So we're just going to leave it. If you need to go ahead and pause to finish writing it down, go ahead and pause now. Alright, we're talking about length and width of a rectangle and how it relates to the perimeter. So our perimeter formula is P equals 2 times the length plus 2 times the width. So we just need an expression. We don't really need the P equals, so we're going to go 2 times x plus 5 over 5x minus 10 plus 2 times 4x minus 3 over x squared minus 25. Both of these expressions factor. Both of the denominators, sorry. This denominator is 5 times the quantity x minus 2. The other side is x plus 5 and x minus 5. So we can go ahead and look at our LCD. Our LCD is the unique factors of the denominators. So we have a factor of 5. We have a factor of x minus 2. And in our second one, I think we're going to need to grab both of those, x plus 5 and x minus 5. So pretty big LCD. Let's go ahead and simplify this first. So I'm going to distribute that 2. I'll get 2x plus 10 over 5 times x minus 2 plus 8x minus 6 over x plus 5 times x minus 5. Now in terms of my LCD, the first expression is, it has the 5 and the x minus 2, but it's missing the x plus 5, x minus 5. We are quickly running out of room. Now, while I'd need to multiply the top by x times 5, or by x plus 5, x minus 5, I know that it's also equivalent to x squared minus 25. So instead of having to FOIL it out before I multiply, I'm just going to write x squared minus 25 on top. And while they look different, the value of this thing is still just 1. The other term is missing the 5 and the x minus 2. So I need to multiply top and bottom by 5 times x minus 2. And I'm going to keep the denominator in factored form, but similarly to what I did before, I'm going to call the top 5x minus 10. Because we know that since we factored it, the 5x minus 2 is the same as 5 times the quantity x minus 2 is the same as 5x minus 10. And the value of this whole thing here is just 1. So now I get to do some foiling. Alright, let's see how much room we have. So 2x times x squared minus 50x. I'm doing this out of order, sorry. X squared times 2x is 2x to the third plus 10x squared minus 50x minus 250. Ooh. And that is way in the wrong place, huh? Way over here. Plus, that's going to give us 40x squared minus 80x minus 30x plus 60. And all of that is over x plus 5, x minus 5, 5, and x minus 2. Sloppy, sloppy, sloppy. And x minus 2. Alright, let's put our like terms together. I'm going to end up here in example 9. I apologize. There's only one cubic on top, so we've got 2x to the third. I got a 10x squared and a 40x squared, so that's 50x squared. And I just can't get it in the right spot today, sorry. I have a negative 50x, a negative 80x, and a negative 30x. Seems like I have negative 160x. And negative 250 plus 60 should be negative 190. Seems like it'd be a weird thing to factor, and it is. Doesn't appear to factor to me. So put it all over one denominator and be done with it. Alright, the directions end with kind of where it says state any restrictions. Because this is a word problem, there are some extra issues with this related to the length needing to be positive and the width needing to be positive. Unfortunately, or fortunately for you, I only have a minute left on this video, so that discussion takes a little more than a minute. I think in terms of grading, all we're going to look at is what keeps the denominator from being 0. So for now, let's just say our restrictions are x cannot be negative 5, 5, or 2. I think in reality, we probably need to be bigger than positive 5. But I'd need to do a few more calculations just to make sure of that. But for grading purposes, we'll end with there. We don't have time to do the last example. We can do it in class on another day if you need. Go ahead and work on this assignment for your homework. Thank you. Have a good day.